Welcome to AMP1's video lecture series. Your exams are based on three things: the lecture videos, the review sheet found in the module section of Eagle Online, and the conferences. The live conferences are provided for all three modes of instruction. The WW, which is truly online. Now the WW, the conferences are optional, highly recommended, but optional, and they will be recorded. Then for the WS, which is online but on a schedule, for those students, the conferences are during your class time and it will be required for attendance. And then the last mode is Flex Campus, since they are also an in-person on a time classroom, is going to be required as a live conference as well. Okay, we'll start with Chapter 1 of the video lecture series. Now keep in mind that the Eagle Online does have a conversion chart between the lecture video series and the chapters that go with our textbook. The lecture series and the conversion chart is found on the module section of Eagle Online. Here's our first slide for Chapter 1, which is Anatomy and Physiology. Anatomy deals with the structure of the body, like your nose, your brain, your arms, your legs, the reproductive organs, the liver, things like that. Those are the anatomies. The physiology is how these structures actually work. Now, one of the themes you have to remember for this class is form and function are related. That means the anatomy affects the physiology. Let's take two quick examples. One example is your red blood cell. If someone that has sickle cell anemia, well, they're going to have a problem where their red blood cell is shaped like a sickle. So we have now a red blood cell, which is your anatomy here, where it now has a deformed shape. Well, that deformed shape is now going to cause a change in the physiology, where now it's not going to carry the full amount of heme or hemoglobin, and therefore it's not going to carry the full amount of oxygen, and that's why they call it sickle cell anemia, because they will not be able to carry the full amount of oxygen. That's why they're going to be sluggish and tired, fatigued very often. Likewise, the shape of the red blood cell being deformed is going to plug up blood vessels and cause clotting problems. So that's your first example of how sickle cell anemia affects both the structure and the function. The second example is cystic fibrosis. Now that is a lung disorder, but can be a GI tract disorder as well. If you imagine a person that has cystic fibrosis, they're sitting in a wheelchair, they're huffing and puffing because they got all this mucus building up in their lungs. They're also skinny and bony. Now let's take a closer look at this. If we have mucus that is now malformed, so you have a wrong and too much of the wrong kind of mucus, that means now your anatomy has changed. What is that going to cause in terms of physiology? Well, too much of the wrong mucus is going to make you drown in your own mucus within your lungs. And that is what happens in cystic fibrosis. The other thing I mentioned is the GI tract. Well, in cystic fibrosis, you have too much of the wrong kind of mucus in the intestines, and you're now not going to absorb your nutrients properly. Therefore, you're going to be bony and skinny. So as you can see, changing the structure can affect its function. And that's your definition of anatomy and physiology. The next thing we have is scientific method. You should understand this slide. The kind of question you're likely to get on this slide for a scientific method are the steps. So as you can see from this slide, you see different steps. And that's what they often ask on a test. Next slide. I don't care for that one. Okay, the slides that I'm skipping are not as important, so that's why I'm skipping them. Okay, this slide here is basically the same information I shared with you, where the anatomy is affecting physiology and vice versa. Okay, this slide is important. On an exam, either my exam or a department exam, and as you have noticed from the syllabus and the information provided on the day 1 announcement, chapters 1, 2, 3, and up to 4 of your textbook will go with the department exam. So what I'm going over now with chapters 1, 2, 3, and 4 will be related to the department exam. So the kind of question you're going to get here are characteristics or features of living things. So what do all living things share in common? The first one is organization. All living things have some degree of organization. Even schools have organization. The next thing you see on the slide there is metabolism. Now, metabolism deals with how the body uses energy. So how the body uses energy. The first term you have under metabolism is anabolism. This is how the energy is used to build things. If you have a lot of building blocks like Legos, and you're building something with Lego blocks, it does take energy to build something with Lego blocks. That's anabolism. Catabolism is the opposite. It also takes energy to break things down, and that's catabolism, to break things down. The next terms we have are growth and development. Now, growth always refers to the increase in the number of cells. So the number of cells. So when someone's, like, if you have a little kid at home and his pants are becoming shorts because he's ever growing taller, that's growth. That's the increase in the number of cells, the size of the cells, the number of cells, and you're just getting bigger. That's growth. Okay, and then related to that is development. Okay, so growth and development. Usually growth is restricted to the number of cells, and development is restricted to the embryonic development. Next slide. Okay, we continue our list of features or characteristics of living things. The next one we have is responsiveness. This is how we respond to stimuli. So if it's really hot outside, then we sweat. Well, that's a response. It's getting very hot, so we're starting to sweat to help us cool ourselves down. If it's cold outside and we start to shiver, the shivering process is also a responsiveness to the cold. The next one is regulation. And the key thing under regulation is a term called homeostasis. You can see that on the slide, homeostasis. Now, homeostasis is a balance. That's what it really is. It's a balance. So under regulation, we have homeostasis. And we're regulating balance. Now, we usually have a balance among 3 regions. So imagine that homeostasis is always about 3 regions, and here they are. The first region is the blood vessel. Okay? The blood vessel, things that are in the blood vessel. The second region is extracellular fluid space. That's the space outside of a cell. And then the third region is intracellular fluid. That's inside the cell. So again, we have the blood vessel, region number 1. Region number 2, extracellular fluid space. And region number 3, intracellular fluid space. So if we're able to maintain the right materials in all of these 3 regions, then we are in a state of homeostasis. When we're not in homeostasis, we are in a state of disease. So when we're not in homeostasis, we're in a state of disease. Now, what takes us out of homeostasis? That would be stress. So stress is something that removes us from homeostasis and then puts us into a state of disease. The last one on our list here is reproduction. Reproduction. And that has to do with the old words of gametes, your testes with sperm, the ovaries with egg. That's reproduction. Okay? Making a new being, making a new organism. And yes, it always deals with sex cells or the gametes. Okay, next slide. Okay, the next thing we have here is a slide. And I call it a slide because it goes from the most simple to the most complex. So you have the chemical level, then the cell level, the tissue level, the organ level, the organ system level, and then the entire organism. Keep in mind that as I go from the lower levels to the upper levels, I'm actually integrating more and more complexity. It also means that I'm adding more and more, not only complexity, but I'm adding more and more interaction. So let's take an example of what I mean by that. If we have, say, a damage to a cell, so I'm at the cell level, damage to the cell. Well, if I damage enough of the cells, for example, in the pancreas, if I damage enough cells and I damage enough tissues, then I damage enough of the organ, the pancreas, now I'm not making insulin anymore, and now I'm going to damage the entire organ, which then can affect how the entire organism is affected. So that's why there's a lot of interrelationship between one level and that of another level. Next slide. Okay, so this is another important slide to show you that we have different levels even among the chemical. So we have the atoms, which are the smallest unit of matter. So chemical level, atoms being the smallest unit of matter. Then if I take many, many atoms together, put them together in a special, unique way, I get molecules. And then if I put those together in a more complex way, I get things like the DNA and the different organs. And when I say organs, I'm talking about organelles within the cells. So this is all about becoming more and more complex. But again, we're putting things together in a specific, unique way. That's an important theme. Next slide. So that was the chemical level. Then the cells, same way. In the cellular level, I'm adding things together. And notice the cell is considered the smallest living structure. So cells are the smallest living structure, because everything else below it would be just basically chemicals. Okay, then we've said that if I take a lot of cells together, put them together in a unique, special way, I get tissues. You should be aware that there's 4 main tissues. That's what other chapters will be about. So the 4 main tissues are epithelial tissue, connective tissue, muscle tissue, and nervous tissue. Do not make up any more and do not subtract any. So these are the 4. Okay, so epithelial tissue, connective tissue, muscle tissue, nervous tissue. It is important to know this slide. Next slide. Okay, then we have our organs. Then organs are put together to make organ systems. Organ systems are put together to make the entire organism. Next slide. Here's a picture version that many textbooks have. So here's a picture version showing the atoms and molecules making up the chemical level. That sounds like a very good test question later on. So the chemical level is atoms and molecules. So atoms and molecules making up the chemical level. Then we have the cell. Then we have the tissue, the organ system, and then the entire organism. And many textbooks have such a picture. Okay, do not care for this slide. These are the different 11 organ systems of the body. I'm going to call these out. They are of value to you. At least you should know that they exist. So we have integumentary system, which is your skin, skeletal system, muscular system, nervous system, endocrine system, cardiovascular system. Continuing, we have lymphatic system, respiratory system, urinary system, digestive system, and the male and female reproductive systems. So those are the 11. At least you should know that they exist. Here's a picture version. Many textbooks have this at the end of chapter 1. Okay. I don't really care for that slide. Okay, anatomic position. This slide is going to be helpful for both the lecture and the lab. So lecture and lab. Now before I go any further, under modules of Eagle Online, you're going to find a section that says Instructors Resources. When you go to Instructors Resources, you will find a section called Anatomical Models. They contain, or that website that you go to, Anatomical Models, it will contain the key models that are used in the lab pre-labeled for you. Your instructor will show it on the day 1 information as well on the first conference. So be aware of it. It is going to help you in the lab tremendously. Going back to our slide here, we have the anatomical position. One of the questions for both lab and lecture is, what does the anatomical position look like? This slide you will need to be able to relate to. So upright stance, feet parallel, facing forward, palms facing forward, that type of thing. So be aware of this slide. Okay, then the next thing we have are called body planes. Now body planes are different slices that you can make. We're going to look at them one by one. The first one we have here is the coronal plane. The coronal plane is a frontal plane. It's a slice that gives you a front half of the body and a back half of the body. So coronal or frontal will be a slice that gives you a front half and a back half of the body. The next one is transverse. This is going to be a cut from the left side of the body all the way to the right, which is going to give you a top half and a bottom half. Sort of like what a samurai sword warrior disgraced at the battlefield get his body chopped up by having a samurai sword go through him, and is going to give a top half and a bottom half. Next slide. Continuing, the next one we have is mid-sagittal. A mid-sagittal is one that goes right down the midline of your body, right between the eyes, between the nose, all the way down. That's going to give you an equal left and right half. So it's called a mid-sagittal. Some people call it a median, which is going to give you an equal left and right. Now, what if I didn't go right down the midline, but just went down, say, down the shoulder? Then that's going to be a sagittal. A sagittal is simply a left and a right, but it does not imply that it's equal. Rather, it is actually unequal. So one more time. Sagittal is simply a left and right. It does not necessarily imply that it's equal, and only mid-sagittal would be an equal left and a right. The last one on our slide is oblique. Oblique is the one that is a diagonal cut. A diagonal cut. Sort of like the way they cut sandwiches sometimes. A diagonal cut. Next slide. Here is a picture version that many textbooks have. So you see the coronal, you see the transverse, and you see the mid-sagittal on this slide. Next slide. Okay. Okay, now I'm on this slide here about anatomical directions or anatomical terms. You're going to find a section under the instructor's resources, under modules, that has the terms given to you. So if you go to the module section under anatomical directions or anatomical terms, you'll find it there. You will need to know them for both lab and lecture. So let me show you one more time. It's under modules. Then under modules, you go to instructor's resources. And then under instructor resources, a little bit halfway down to 3/4 down, you're going to find something called anatomical terms. Those are the terms you're going to need to know for lab and lecture. Okay. They are related to these pictures, but you need to know the terms. I would put them on a flashcard. So that is the study strategy that I'm offering. I would put them on a flashcard. Your slide that I spoke of under modules is going to look something like this. So it's going to look something like this. So you'll have to put this on a flashcard. You'll find it under module section. Next slide. Here's another slide showing you the continuation of that. Again, under modules, instructor's resources, you'll find these directional terms. These are further terms you'll find in that list as well. Now, why this is important is because of the lab. You need to know these because they'll be helpful for some of the lecture questions, but especially for the lab. Here's the back half. Okay, now we come to body cavities. Body cavities are also provided as a slide under modules, instructor's resources, and the title will be body cavities. I like that particular one that I've provided because it has a nice picturization. I would put that onto a flashcard approach as well. You will need to know what structures are found within a given body cavity. So I will need to know what's found within a given body cavity. Okay. So here we have, for example, cranial cavity. And notice it has the brain in it. Okay. So that is the kind of thing that the slide is asking for. It's under modules, instructor's resources, and a section called body cavities. There's an image. You will need to know what is found within each of the body cavities. Next slide. Here are more examples of the same thing. Now the next thing I'm on are called membranes. So the first membrane that we're coming across is called serous membrane. Serous membrane produces serous fluid. So serous membrane produces serous fluid. The purpose of serous fluid is a lubricant. So your entire abdominal cavity, your big belly with all the major organs down there, they actually have what's called serous membrane producing serous fluid, which is acting as a lubricant. It is what allows the organs to glide past each other without friction, without pain. Someone that has a belly surgery and they've opened up the belly and then they've fixed everything that needs fixing and then put it back together again, it takes about 7 to 10 days for enough of the fluid to come back. In the meantime, every sneeze, every cough, every rolling over in bed, which causes the organs to rub against each other, is going to hurt. It feels like a pitchfork. It's going to hurt. So serous membrane, serous fluid. Here are the body cavities. Again, I've already given you the slide that I care for. under the module section of Eagle Online, under Instructors Resources. Please use that one. You can use this one if you want, but I prefer the one I've given you. Next slide. Don't care. Okay, this term I do care. Again, this is a continuation of what is found within the body cavities. So as you can see, we have the thoracic cavity with the word mediastinum. And notice the organs that are found in this section. That is why I said that you need to know by flashcard format the mediastinum, the different structures found in different body cavities. Now the next one I want to elaborate on is this part right here. This has to do with the heart. So you've got mediastinum where the heart fits in. So there's a space within the thoracic cavity called mediastinum. That's where the heart fits in. But then even the heart has layering. So you have the outer bag of the heart called pericardium. It has layers like parietal, visceral, and then itself a space in between called pericardial cavity. So this is what I mean by knowing the different cavities and the different membranes that make them up. And notice pericardium is a serous membrane because it has a lubricant to allow the heart to beat, and that's why you don't hear the banging against the walls, because there's a lubricant. All right, next slide. So this one's important. Now comes the lungs. Lungs have the same thing. So notice, if you haven't figured it out yet, that these cavities are basically a tube within a tube within a tube. Okay, like a bag within a bag within a bag. Different layerings. Well, that's what we have here. Even the lungs have different layerings. So be aware of the different layerings. Again, use these slides, or you can use the picture form or the chart form I provided under Modules, Instructors, Resources. And yes, you will need to know the different membranes. Again, this too is a serous membrane so far, and the different cavities. Okay. Here's a picture version. You can use that if you want. Now we have the abdominal cavity. So even the abdominal cavity is broken down to the abdominal and the pelvic. So abdominal pelvic is abdominal and pelvic. Notice you do need to know what organs are found within each. Okay. Yes, you do need to know the body cavities and the organs found within each. So this slide and the resource provided under Modules, Instructor Resources will help you. Okay, now we have this word, peritoneum. Okay, now the peritoneum, again, we have a serous membrane, and the peritoneum is broken down into these categories. Now there's one that is missing from this slide, and I'll go over it as I go over these. The first one on our list here is parietal. That has to do with the sides of your abdominal cavity. So the sides of your abdominal cavity are parietal peritoneum. So at the side of your abdominal cavity. Then we have visceral. Visceral is the front. It's the front part of your abdominal cavity, the visceral. The one that's missing from this list so far is retroperitoneum. The retro is towards the back. Now why retro is important for now and in the future is retro is where your kidneys belong to. So your kidneys are housed in the retroperitoneum. So I'll repeat these three before I finish the slide. We have the parietal, which is the side of the abdominal cavity. The visceral, which is the front of the abdominal cavity. The retro, which is the back of the abdominal cavity where the kidneys are housed. And then the last term we see at the bottom is the peritoneal cavity. That is the space between them. And that space contains the serous fluid that allows the organs to glide past each other. Okay, next slide. Here's a picture version, not that great. Okay. Now this picture is also available under the modules Instructors Resources. So under modules Instructor Resources, this particular chart is labeled as tic-tac-toe. And as you can see why it would be labeled as a tic-tac-toe. You will need to label this picture exactly as shown. So exactly as shown. Now notice the left side of the picture is labeled right. The right side of the picture is labeled left. The reason for that, it is always from the patient's perspective. So if you're describing the right leg of the patient, but you're at the foot of the bed, and it looks like to be your left as an observer, but it's the patient's right, you don't write it from your perspective. You always write it down from the patient's point of view. So it's always the patient's right or the patient's left. Be able to reproduce this tic-tac-toe. Okay. The quadrants, just be aware of them. I'm not too picky on the quadrants, nor will the lab be. Okay, I've already mentioned the term homeostasis to you a moment ago. I told you that it's a perfect state of tranquility among the three regions. So it'll be among the blood vessel, the extracellular fluid, intracellular fluid, right? Those three spaces. Well, it turns out that you can actually expand that idea to the entire body as well, because it's not only related to the blood vessels, it's not only related to the outside of the cell, which is extracellular fluid space, and not only to the intracellular fluid space, which is inside the cell. It is pretty much the entire body. Now, whenever you're not in homeostasis, I told you that you're in a state of disease. And I said earlier that the state of disease is because of the stress that was put on homeostasis. Well, now we're going to look at all the different stressors. Now, the first thing we have to understand about homeostasis is the receptor idea. You don't know what is going around or happening around you unless you have some kind of receptor. Okay. So you have receptors on your skin to let you know whether it's hot or cold or pain or touch, that kind of thing. So you have to have a receptor. Then the receptor has to take information to the control center, whether it is your nervous system or whether it's your endocrine system. And notice at the bottom down here, I have nervous system and endocrine system. Right? So nervous system, endocrine system. Now, one of the themes that you should learn in A&P 1, which very much carry over to A&P 2, is nervous is your nervous system, your electrical. So nervous system is your nervous system, your electrical. The endocrine system is your hormone or chemical. So Nimish, what is the big mantra for A&P 1 and definitely for A&P 2? The only way our body responds to the environment, both outside and inside, is either electrically, which is the nervous system, or chemically, which is the hormones or endocrine system. And that is a big theme in A&P 2. So anything that happens in the body will either be responded to electrically or responded to chemically, and that's your control center. Then, of course, we have to have an output. The output is your effector. So the output is effector. Now, I'm going to say something now that comes up in a future chapter, and that is effectors are muscles or glands. So effectors are muscles or glands. Very, very important. So effectors are muscles or glands. Next slide. The first kind of feedback that we have is called negative feedback. Now, instead of me reading all of this, I'm going to give you an example. Now, first of all, negative feedback happens to be most of the situations in the body. Negative feedback tries to undo the event over time. So it tries to undo the event over time. Some people say that it negates the effect or it goes in the opposite direction. That's all possibilities of negative feedback. So it undoes the event over time. That means it lessens the effect. So a good example is if your blood sugar is going up, then your body is going to try to lower the blood sugar. If your body temperature is going up, then your body is going to try to lower it. Okay, that's what I mean by opposites. Some people call it a seesaw effect. That's exactly right. If one side's going up, then the body is going to try to raise the opposite side so it can make it go down. So it's the seesaw effect. Right? So it decreases the effect, it undoes the effect over time. Most situations are actually negative feedback. So the textbook rather gives an example of your body temperature. That's a negative feedback. Okay, continued. Okay, here's a picture of a nice setup showing you the stimulus, the receptor, the control center, and then the effector. And if you look really carefully down here, notice it's something I said to you a moment ago. Effectors are muscles or glands. You can see that at the bottom box here under effector. So effectors are muscles or glands. Okay, so here's an example of someone in the cold weather. That's a negative feedback setup. The other kind of situation we have, and again, I don't want you to memorize all of the different examples of negative feedback. Just be aware of them, but you don't have to memorize them. Remember, the object of negative feedback is to undo the event over time. So if your blood sugar goes up, then somehow you're going to lower your blood sugar. Okay, that's all negative feedback. The next type we have is positive feedback. The positive feedback is going to reinforce the event over time. That means it's going to make it stronger. It's going to reinforce the event over time. The two examples to keep in mind for that is childbirth. So in childbirth, when you have a true labor pains, so in childbirth with true labor pains, you're going to find that the frequency and the strength of the contractions get stronger and stronger as the baby's ready to come out. That's true labor. The uterus contractions. So the uterus contractions, positive feedback. The next example often seen on a test is blood clotting. So when your blood starts to clot, it normally will continue to clot. It is a positive feedback loop. And as you can see at the very, very bottom of the slide for positive feedback, it's the two that I provided. The blood clotting and the uterine contraction during true labor. And here's a picture version of that for the breastfeeding and the positive feedback. Okay, I've already mentioned disease. I told you disease is anything that takes you out of homeostasis. Okay, don't care for this slide. I don't care for this slide. They're not going to ask you on a test. Okay, don't care. Don't care. I don't care. Don't care. Okay, that takes care of Chapter 1.